Bismillahirrahmanirrahim. Everyone come to page number 85. Okay, we already studied a couple of theory, and based on that we are going to solve some numerical example. Okay, page number 85. We are going to discuss about the numerical example 2.1. Okay, the angle between two vector quantities with magnitude 20 Newton and 60 Newton is 30 degree. What is the magnitude of the resultant? We already know how to find out the resultant vector when two vectors are acting on a particle at a certain angle, right? So that is the parallelogram law, if you remember. This is one vector and this is another vector. We know that one is 20 Newton, another one is 60 Newton, and the angle between them is already given as 30 degree. Yes, 30 degree. Now the resultant will be acting. If I complete the parallelogram, so the resultant will be acting along the diagonal of it, right? And we know how to find out the value of it. If you remember, we learned this formula. So all we need to do is just replace the value. You can consider P is 20 Newton and Q is 60 Newton, okay? And the alpha, that is the angle, here it is 30 degree. So it will be 20 square plus 60 square plus 2 into 20 into 60 into cos 30 degree. So 20 square, it will give us 400. 60 square will give us 3600. And 40, 2400 into cos 30 has a value of root 3 by 2. So it will become 1200. So 3000 plus 4000 plus 1200 root 3. So from here, if I do the calculation, I will get the answer 77.96 Newton. Kindly do the calculation yourself and check whether this answer is correct or not. Okay. I should be getting 77.96 Newton. I hope you all have calculator, as this is physics class. Yes, the calculator should be available around you. Okay. During the math and physics period, keep the calculator in your hand. Okay. Did you get the answer?
Yes, sir.
Okay. So this is numerical example 2.1. We will discuss about the second numerical example now. Kindly take a look, read out the question. Okay. So the second numerical example, if you see a body is pulled towards east with 50 Newton force, then it is pulled towards north with 20 Newton force, making an angle 60 degree with the east. So find the magnitude and direction of the resultant force. If you want to actually take a look at the figure, okay, is it drawn? Oh, actually the figure we can draw it ourselves. Okay, this is the east direction. Generally, actually, you must have a clear idea about the directions. Okay, because many times they will say that yeah, the force is being exerted in east direction, so you must know which one is east direction. This is east, this is west, this is north, this is south. Okay, always remember, in the upper direction it is north, downward it is the south, and if you want to keep the south in your right side, and then the side you will be facing will be the east, and the opposite of east will be the west. Okay, so here in east direction I am applying a force, and again they said that I'm applying another force. I'm making an angle 60° with the east in the north direction. So actually I will be applying the force in this direction. Okay, in the north part, making an angle 60° with the east. So here I'm applying the force, and angle 60° has been made. So 50 Newton and 20 Newton. One is 50 Newton, another is 20 Newton. Okay. Find the magnitude and direction. Now this is a little bit interesting, because earlier in the first numerical example you have been asked to find out only the magnitude, not the direction. But now we need to find out the direction also. Okay. That means we need to calculate the value of theta. If you remember, we already developed expression for that.
Yes.
Okay. So now I will just complete the parallelogram, and the resultant will be acting along the diagonal of it, right? So here, let me discuss the given information. Oh, point answer nahi. Okay. So the let us list out the given information. Let us consider P is in this direction, which is 50 Newton, and Q is 20 Newton, and the angle between the vectors, that is alpha, is 60°. Okay. Now we need to know the magnitude of the resultant, that is R, and the direction, which is expressed by theta. Now we have to specify that you are considering theta between which two vectors. So one is resultant, the angle which, let us say I have considered with P. This angle I have considered theta. So this theta I have to find out. Now you might ask, sir, what will happen if I take this angle to be theta? Then the expression of theta will be changed. Okay, how it will change? We will take a look. No problem. R is equal to, we already know, P square plus Q square plus 2PQ cos alpha. So P square means I will get 50 square. $62.45. 62.45 Newton. Okay, so this is the magnitude. Now we will find out the direction. Before I start finding out the direction, I want to ask you, do you have any doubt here?
No.
Okay, so direction we already know, tan inverse.
হ্যালো স্যার
হ্যাঁ বলো।
স্যার আমার নেটে সমস্যা দিচ্ছে, সো আমি পরে রেকর্ডিংটা দেখে আমি বলবো।
ক্লাস করবে না এখন?
না স্যার করবো, মেসেজে খাচ্ছে, বারবার কথা আটকাচ্ছে। সো
আচ্ছা ঠিক আছে, ওকে। So this is going to be the expression. Theta is equal to tan inverse Q sin alpha divided by P plus Q cos alpha. Now this theta you have considered with P. We have considered P 50 Newton, right? That is why this expression is like this. If you consider the angle theta between the resultant and the vector P, then this P will be separate. Q will be with Q sin alpha and Q cos alpha. Now let us say I have considered the angle between the resultant and Q to be the theta. Then what will happen? P and Q, they will exchange their places. Okay, so it will be P sin alpha divided by Q plus P cos alpha. I hope this is clear. Okay, so never get confused that how the expression is going to change depending on the angle you consider in the figure. Okay. Now we just need to replace the values. Okay, 20 sine alpha is 60 degree. P is 50 plus 20 cos 60 degree. Okay, so from here you can easily find out the value, right? Can you find out? Twenty I got it as 16.1 degree. Is it correct? Yes, 16.1 degree. Okay, so anybody has any doubt? Those who joined new, like Nurnavi, is Morshad here? No, Morshad is not here.
No, no.
Okay, so Nurnavi, did you watch the previous videos as I provided?
I will watch it today.
Okay. I requested you to watch it before the next class so that it is easy for you to understand what I discussed today. But okay,
Okay, sir.
now as you didn't watch it, so you might be having some problem here understanding this. Okay, so watch the videos and then you can ask me out in the next class. Okay, so this is
Okay,
the second example, and the third example I will tell you to go through at home. Okay, you can do it yourself, inshallah. So if you have any problem, you may ask me in the following class. And then about numerical example 2.4, that is based on resolution of resolution of vectors. So that is another topic. Okay, so we will go through the topic of resolution of vector now. Then we will solve numerical example 2.4. So resolution of vector means breaking down the vector into two components. Okay. Resolution of vector. Okay, page number 16. Everyone come to page number 16. So in the earlier article, we have seen that one vector can be found by adding more than one vector. Yes. In parallelogram, we saw that P and Q, two separate vectors were there, and we found the resultant of it by adding them, right? So if I can get one vector by adding two or more than two vectors, then that vector can again be further divided into two or three vectors. This is what is resolution of vector. Okay, breaking down one vector into two or more than two components, okay, depending on the dimension. Okay, now we are considering only two dimension, that is x-axis and y-axis, right? So that is why here only we will try resolute the vector into two components. Okay, one x component, another one is y component. So let us go through the paragraph. In the earlier article, we have seen that one vector can be found by adding more than one vector. Thus, it is possible to divide one vector in two or more vectors. Yes, this is possible. The method of dividing a vector into two or more vectors is called resolution of vector. Okay, this is what I just said. The resolved parts are called components of vector. Now, and we understand this, right? Whenever we have a machine, we open the machine up, okay? So each part is called the component of the machine. So this is like a vector, okay? So vector, when we resolute it into two or more part, okay, those part will be known as component of the vector. So if I resolute the vector in x-axis and y-axis, so I will say the component along x-axis, the component along y-axis. This will be the two vectors. Acha. Now, in two ways, I can divide them. Okay, in two ways. First one is, let us say, I have a vector like this. I want to break it up into two perpendicular components. That means one component will be along x direction. Okay, this is the component along x direction, and I can have another component along y direction. Okay, I can have another uh, in the y direction, and the angle between the component is 90°. That is why we are saying it, these are perpendicular components. These are the components who are perpendicular to each other. This is one way to resolute the vector. Okay, another way is the angle can be any. Okay, this is the vector. I will divide the vector into this part, and another vector is in this part. The angle between them can be any angle. Okay, not specified. We are actually more interested towards this. Okay, we will try do our detailed calculation about this, not this. We will just, for this case, where the angle is unknown between the components, we will just know the equation, how to calculate just the equation. Okay, and for this one we will see the derivation also. Okay, so here in your level, this one has been discussed in more details, not this. Okay, for this only the equations are given, not the derivation. Actually, I didn't see any numerical example also based on this type. So let us focus on this one. Acha. So this is resolution of vector into two perpendicular components. That means the angle between them will be 90°. This is very important to understand, because in this case we know the angle between them, that is 90°, and we will put it to use in many cases. Achha. So now let us see perpendicular components, page number 60. A vector can be resolved in any two directions. Yes, any two direction we can do. Now, if a vector is resolved into two components in such a way that the two components make right angle to each other, this is what they did, right? The two components have made right angle with each other. That is, they are perpendicular to each other, then the components are called perpendicular components. In figure 2.2a, a vector R is resolved into two perpendicular components, x and y. The figure is just like this, right? Okay. So R, this is the vector R which has been resolved into two perpendicular components, x and y. So as it is vector, I should be putting arrow marks. Do not forget to put the arrow marks. The one component of R is OA. Yes, X they have denoted by OA, and this is definitely OB. Okay. Making an angle alpha with R. Okay, they have given this angle to be alpha. Okay. The other component OBY is perpendicular to X. Yes. Now in the triangle OAC, OA, this point they have considered to be C. From this triangle, what we can write? OAC triangle. what I can write equal to cos theta or cos alpha is equal to, see, this is the adjacent, and as this is a 90 degree, okay, so the opposite side of this will be the hypotenuse, right? So adjacent by hypotenuse. Adjacent is OA, hypotenuse is OC, and OA we saw that it is vector x, and OC, this is R. So from here what I can write, if I cross multiply, okay, cos alpha divided by 1 is always there, we consider. So 1 into x will become x, R into cos alpha will become R cos alpha. This is equation 1. Then if I apply sine alpha, what I'm going to get? Sine alpha is equal to oppo by hypo. So this is alpha, the opposite side of this is AC. So AC, and hypotenuse, we know that it is OC. So sine alpha is equal to AC. AC is this side, right? Now, which is similar to OB. So OB is represented by Y. And OC is the hypotenuse, that is the resultant R. So here also, if I do the cross multiplication, I will get Y is equal to R sine alpha. Anybody has any doubt till now? Anybody have any doubt? These are the two expressions actually we need to know. We want to know the value of the components, right? This is the way to know the value of the components. If you know the vector magnitude R, and if you know the angle between the vector R and one of the component, then you can easily find out the value. Okay? তবে এখানে একটা জিনিস একটু খেয়াল করতে হবে, আরটা যে কম্পোনেন্টের সাথে আলফা অ্যাঙ্গেল মেক করে সেটার ভ্যালু হবে কি cos আলফা, আর অন্য আরেকটা যেটা থাকবে সেটা হবে r sin আলফা। ঠিক আছে, যেমন মনে করো আমি তোমাদেরকে যদি একটা ভেক্টর এখানে এভাবে দিয়ে দিই, মনে করো এটার ম্যাগনিটিউড হচ্ছে 5, এখন এটাকে দুইটা পারপেন্ডিকুলার কম্পোনেন্ট আমি তোমাকে ভাঙতে বললাম। তো এইটা যদি 30 ডিগ্রি হয়, তাহলে এই সাইডেরটা হবে 5 cos 30, আর এই সাইডেরটা হবে 5 sin 30। এখন মনে করো কেউ একজন বললো যে স্যার আমি নিচেরটার সাথে অ্যাঙ্গেল নিতে চাই না, ওকে, ইউ হ্যাভ দ্য লিবার্টি টু ডু দ্যাট। এটা মনে করো 7 এবং এই অ্যাঙ্গেলটা হচ্ছে 20 ডিগ্রি, তাহলে এই দিকেরটা এখন হয়ে যাবে 7 cos 20 ডিগ্রি, মানে যে দিকে ভেক্টরের সাথে এটা অ্যাঙ্গেল ক্রিয়েট করবে সেই দিকেরটা হবে cos, এবং অন্য সাইডেটা কি হবে, এখন নিচেরটা হয়ে যাবে sin 20। ইটস নট লাইক দ্যাট যে নিচে যেটা বা হরাইজন্টাল যেটা থাকবে সেটাই সবসময় cos হবে, আর সবসময় তার অন টপ অফ ভার্টিক্যালটা হবে sin। দ্যাট ইজ নাথিং লাইক দ্যাট, ওকে। You must remember that যেটার সাথে অ্যাঙ্গেল থাকবে সেটাই হবে cos, এবং যেটার সাথে অ্যাঙ্গেল থাকবে না সেটাই হবে sin। Okay? Anybody has any doubt?
স্যার যে যখন সাইনেরটা নিছেন তখন অ্যাঙ্গেল কোনটা ধরছেন?
This 20 degree only. Actually, this is a little bit interesting. If you see, I will explain. Acha, here it is clear.
Yeah.
Calculation is clear. These two expressions are very important. If you want to find out the component along x-axis with which the r has made an angle alpha, then it will be r cos alpha. And if you want to find out the perpendicular component, it is r sin alpha. Okay, this is what we will use to solve the numerical example 2.4. Okay. Acha. Now, actually the component, the rule to find out the component is like this. Okay, let us say I want to find out the component along x-axis. So it is, the value should be magnitude of the vector. See, magnitude of the vector, which is in our case this is r, right? So magnitude of the vector, this one will be there, okay, into cos, into cos এর পর একটা angle থাকে না, that angle will be the angle between the vector and component and that component. Now, this is the basic theory, okay? So how we can apply this in our case? See, x is equal to magnitude of the vector, that is r here, right? So I will write r, then I have cos, so I will write cos, the angle between the vector and that component. So we are considering x now. So it is r, okay, and the component is x. The angle between them is alpha. Correct or not? The angle between them is alpha, so I will write cos alpha. So this is just the previous. But what about y? If I write about y, what it is going to come? At first, magnitude of the vector should be there. So again, I will write r. Then cos is there. So I will write cos. Then the angle between that vector and the component. Now we are considering y component, right? So what is the angle between y component and r? Can anybody tell me what is the value of this angle? You should be able to tell me. Acha, take a look. If this is 30 degree, what is the value of this angle?
So 90 degree minus alpha.
Very good. Okay. If this is 30 degree, then this is going to be 60 degree because together they are forming 90 degree, right? So if this is 30 degree, then it will be 90 minus 30, which is 60 degree. Similarly, if it is alpha, then this should be 90 minus alpha. Correct or not? Because both of them together are forming an angle of 90 degree, right? So if it is alpha, it should be 90 minus alpha. Now after cos, what I should be writing? The angle between this component and the vector, which is 90 minus alpha. So cos 90 minus alpha. Now if you remember in grade 10 higher math trigonometry, we studied this, right? 90 can be written as pi by 2. So we have the odd multiple of pi by 2. So if you have odd multiple of pi by 2, what I should be writing? The cos will be changed to sine, if you remember. And then we have to check whether then alpha is there, we will write alpha. Now we do not know whether it will be plus or minus. We need to check the quadrant. So if you check the quadrant, let us see in which quadrant it falls. Pi by 2. So from here we will go to pi by 2. Then minus alpha, that means we will come back to the first quadrant. And in first quadrant, everyone is positive. That is why y is equal to r sine alpha. Okay. So if you remember just this basic, okay, this basic that if you want to find out the component of any vector, all you have to do is just take the magnitude of that vector and write cos and the angle between that vector and the component which you are calculating. If it is x, then the component and x between them, what is the angle? And if you are finding out y, okay, then magnitude of the vector and the cos of the angle between them. Okay, so if you write it in this way, then you don't have to take any headache about sine alpha. Everything you can write along cos alpha, and whenever it is supposed to come sine alpha, it will automatically come. Okay, anybody have any question? Lamia, বুঝতে পারছো কিছু?
Ji sir.
Okay, Sadia,
Yes, sir.
Ipul,
Yes, sir.
okay, Shiham, তোমার কি খবর? কোনো কথা বলতেছো না?
Yes, sir.
ও বাপরে, শিহামা তো দেখি আমার থেকে বেশি ঘুম আসতেছে। ওকে ওকে, আচ্ছা। So I will just write the equation. If you can see the equation for components in any two direction. Till now we were discussing about the perpendicular components, right? The components who are perpendicular to each other. But now we are going to just write the equation without developing it. Okay, in this level it hasn't been shown. So we will just get to know if the case is not like this, that the components are not perpendicular to each other. So in that case, what will happen? Okay, this is our main vector. Okay, this one has been resolved into two components. Okay, now if I say that this angle is alpha and this angle is beta, This angle is alpha, this angle is beta. Then this is x and this is y component. So how I can calculate x? X will be equal to r sine beta divided by alpha plus beta, and y will be equal to r sine alpha, sine alpha plus beta, sine alpha plus beta. So this is going to be the equation, okay? Most probably we are not going to use it, but still, to be on the safer side, we need to keep the equations in our mind, so that if an exception occurs in the exam and some numerical problem is there regarding this topic, then you may answer. Okay. Acha, as I can see, I have two period with you today, right? So one period has already been finished, and the meeting is also for only 40 minutes. So what I will do, I will finish this meeting and start another meeting after 5 minutes. Okay, you may have a break of 5 minutes. Then we will start our next class, inshallah. Okay, and the next topic that we are going to discuss.
Okay,
Sir.
sir.
Huh? It is easier to pull a
Yes,
long
sir.
one than to push. Okay, we will take a look at this topic. Within this 5 minutes, if you want, you can have a look so that it is easier for you to understand when I discuss. Okay. Assalamu alaikum wa rahmatullah wa barakatuh.